In this lesson, we're going to look at two things, though they're very much related. The first is the quadratic formula, and then the second is the discriminant, and we're looking at them to help us solve quadratics. So if you have a quadratic in something that looks like 0 equals ax squared plus bx plus c, where a, b, and c are just parameters, so they'll take on some sort of numerical value, and you want to solve for x. The quadratic formula is one way to do that. And one thing that is, I think, quite nice about it is that it's going to work for any quadratic, assuming that there are solutions. Or alternatively, it will show us that there are not any solutions. I would say this formula is useful enough that it is worth memorizing it. I think in maths, it's nice that we don't have to memorize much, but I would say this one is one worth memorizing. So one way you could do that is if you just write it on your hand or on your arm for a couple of days in a row, it'll probably stay in your head. So here it is. If you've got your formula, your quadratic, that it'll be 0 equals, or maybe the 0 equals is at the end, but ax squared plus bx plus c. So you've got your parameters a, b, and c. Those parameters you would just sub into this formula. And so yeah, here it is. A couple of things to be wary of. There's this plus or minus here. So you're often going to get two solutions, one where you're doing the plus of this and one where you're doing the minus. Another one to be a bit careful of is how it's b squared here. Well, it's all of b squared, right? So if this had a negative value, you're going to be squaring that, right? And if you square a negative, you end up with a positive. So a couple of things like that worth being careful of. Let's do an example and we can see how that works. So here we are. If you really want to take your time with this stuff, what you could do is right at the top, you could write in what each of your parameters are. So if we look at this, our parameter a is 2, the coefficient of x squared. Our parameter b is -5, or -5, and c is 3. And so there we go, not too bad. And then here we go. So what we want to do is go, all right, well, x equals negative b, so that becomes +5, plus or minus the root of b squared, so -5 all squared, take 4 times a, which is 2, times c, which is 3, all over 2a, so 2 times 2. So from there, I would just start simplifying. I haven't given myself a huge amount of space here. So we've got 5 plus or minus the root of, so that'll be -5 all squared is 25. Take away, so 2 times 3 is 6, times 4 is 24. And that is over 4. Just going to draw myself a line here. So x is, we've got 5 plus or minus, well, 25 take 4 is 1, and the square root of 1 is 1 itself, right? So we've got this. Now I just split it up into my two options. So if I were adding, I would have 6 over 4. And if I was subtracting 1 from that 5, I would get 4 over 4. So just a little comma here. And the other option is, 4 over 4, which is 1. And this other one can be simplified to what? 3 on 2. Yep. So it's either 3 or 2, or 3 on 2, or it's 1. Often we write that in ascending order. Here I've got it in descending order. Doesn't really matter. Those are your two solutions. There you go. So there it is. Now, here is another one. So if you'd like, you could have a go at that yourself. Pause the video and I'll show you the solution in just a moment. Here it is, the solution, all written out nicely for you. So yeah, I mean, the thing is, one thing that makes this one a bit more difficult is it's not written in the right order, right? It's not written ax squared plus bx plus c. We've got the first term is x to the power 1. So we need to first rewrite it in the right form and then get out our parameters, put them into the quadratic formula. Out comes x. Our two values of x. Okay. The other thing we want to talk about is this thing called the discriminant. Now, the discriminant is the bit of the quadratic formula that finds itself under the square root sign. So It's not the square root sign. The square root sign isn't involved, as in the discriminant itself. It's actually just b squared take 4ac. Yeah. Now, why is it called the discriminant? It's because it helps us discriminate between how many solutions we're going to get. So as in, I'm using the word discriminate, not as in the bad thing of being mean to people, as in discriminate between two things, or in this case, between three things, as in work out how they're different. So if you think about it, I mean, have a think of these two questions. So what can it tell us, and why does this work? And I'll explain in just a moment, so feel free to pause. The way it does work is, if you think about it, if we just kind of forget what it actually is, we just look at this bit down here, it's the plus or minus bit, and it's got a square root sign. So if you put in any value that is a positive number, you're going to be plus or minusing perhaps some third, maybe it'll simplify to a whole number, but you're adding and subtracting something. So you're going to end up with two different answers for x, right? Whereas if it was 0, if this whole thing evaluated down to 0, you're plussing and minusing nothing. So you've really just got the one answer, whatever minus b on 2a is. And so there's only one solution to your quadratic. The final option is if you were to end up with a negative number here for your discriminant, well, we know we can't take the square root of a negative number. So there would be no solutions to our quadratic. So to sum all that up, those are our rules. Just using some inequalities here. And yeah, so hopefully that makes sense, just if you think about how this plus or minusing is working, and also how a square root sign works. Let's have a go at some practice ones. Just using the discriminant. So now we actually don't need the whole quadratic formula. We just need the bit. So we use delta. Delta, as it happens, as the name kind of suggests, it's the Greek letter for d. So we use that for the discriminant. B squared take 4ac. So for this first one, so b is -3, a is -2, c is 1. Yeah, so the negative signs stick with the parameter, because normally it's ax squared plus bx plus c. There's no negative signs here, so we have to include them. So the discriminant here for this first one, so b squared -3 all squared is 9. Take away 4 times -2 times 1. So 9, it'll be +8. So already I can see this is going to be a positive number. Don't even have to work it out. 17. So 17 is greater than 0. The discriminant is greater than 0. Therefore, this quadratic will have two solutions. All right, let's figure out the next one. So if I just draw something down here, so what a is in this case, just separate this out. So a is 4, b is 2, and c is 2. Okay, so delta is going to be, just making a bit of a mess here, but all right, so delta, our discriminant is, so b squared, so it'll be 2 squared, take 4 times 4 times, oh, what was c? C was 2 as well, times 2. So that's going to give us, so 4 take, 16 times 2 is 32. So you can see this is going to be a negative number, isn't it? -28, I believe. Now, so for this one, we've got that our discriminant here is -28, and that is a negative number. So the discriminant is less than 0. It's negative, therefore no solutions. Yeah. If you were to put that value of your action to try and use the quadratic formula, you'd have a negative number under your square root sign. And so we'd have to stop there and go, well, it doesn't work. It's because there are no solutions to this quadratic. You might remember solutions to a quadratic when you set it. So, normally you might see it as y equals ax squared plus bx plus c. What we're doing is we're making y 0. And you might remember, if you do that, you're finding the x-intercepts. So this is saying there's no x-intercepts. So probably what this quadratic would look like is something like that. Pretty bad drawing, but you'd see there's no solutions or no x-intercepts. Yeah. Okay. That is it for looking at the quadratic formula and the discriminant. So just to sum up, the quadratic formula, it's a useful tool for us to quickly get solutions to a quadratic, so x-intercepts really, and the discriminant is an even quicker way to tell us how many solutions we're going to be getting. All right, thanks for watching.